So they want us to take the derivative of this. And to do that, we need the quotient rule. So first off, we need to prove the quotient rule. And we're going to do it with a similar method as last night with the product rule. It's going to take a lot of paper. And you know what? I don't want to do it on blank paper. Let's pull up some graph paper. So, template, grid, apply. Okay. So here's what we're going to have. So what is the quotient rule? So we have some function. We'll call the function h of x. And that function is equal to f of x divided by g of x. And we want to take the derivative of it. So first off, let's remember what the definition of the derivative is, because that's critical here. So the limit definition of the derivative, which is the main definition of the derivative, is the limit as h approaches 0 of f of x plus h minus f of x over h. So what we're going to do is we're going to start with the limit definition of h of x. And we're going to work that through and we're going to see what happens. So let's apply it. So h of x, I guess we can write it all out to be clear. So first off, remember this h down here and h of x, those are unrelated. H is like a variable that's going to be different than the function of h. Those are totally unrelated. So let's write it out first. So we're going to do the limit as h approaches 0 of h of x plus h minus h of x over h. And that's super confusing now, but it gets less confusing because we're just going to get rid of the h function in the next step. Because what is the h function but f over g? So we're going to have f of x plus h over g of x plus h minus f of x over g of x, all of that over h. Okay, beautiful. So see how we're just using the limit definition to find the derivative of h. So let's just keep working through. So my idea usually is if we've got two fractions, we probably want to combine them. So let's combine those fractions using common denominator. So we'll do that times that and that times that. So we're going to have g of x times f of x plus h minus f of x times g of x plus h over g of x plus h times g of x. And then all of that over h. And then, of course, the limit as h approaches 0. All right. Awesome. That's not that bad. We need one more piece of paper so we can continue down. So what are we going to do next? Well, now we have a fraction divided by h. So let's just remember that if we're dividing by h, you just keep change flip. So that's like multiplying by 1 over h. So we're really just going to end up putting this h on the bottom of this fraction here. So let's just do that. That's also going to be multiplied by h. Okay. Now comes the bit wacky part. So it's similar to what we did last night. So let's take this entire expression and copy it and bring it down. And we're going to add that little middle thing like we did last night for the product rule. So let's give us some room here in the middle and remember sort of what we want. So we're thinking about this limit definition up here, f of x plus h minus f of x. We're trying to build that. So in order to have that, we're going to need a minus f of x here. I'm going to do that in a different color because this is the thing we're adding in. So we're going to do a minus f of x here so that we have the f of x plus h minus f of x. But then, in order to factor out g of x, because we have to get the g of x away from both of them, so that's why we have to be subtracting minus f of x times g of x, because that's what's just going to make it work out. But then, of course, the reason this works, you can't just randomly subtract something. So to make up for it, we're just going to add it back. So we have minus f of x times g of x plus f of x times g of x. And so, of course, those would just cancel out if we wanted them to, but we don't want them to because we're going to use that to make some other magic happen. So now what are we going to do? We're going to look at these two parts, similar to what we did with the product rule, and we're going to factor out what we can. So let's just rewrite it first. So for the first section there, we're going to factor out g of x. And then what are we left with? Well, the f of x plus h minus f of x. And then for the second part, what we're going to do is see how we have like our g of x plus h and our g of x? That's kind of what we're looking at. But we want the g of x plus h to be the positive one. So we're actually going to factor out a negative, and then we got to factor out the f of x. So see, now we'll just swap it around because this was negative g of x plus h, but since we factored out the negative, now it's a positive g of x plus h. And then here, this was positive, but since we factored out the negative, now that's minus g of x. And then, of course, all of that is still over the same thing. G of x plus h times g of x times h. And, of course, that's all the limit as h approaches 0. All right, beautiful. We're almost there. So now what we could do is we could split this up into two separate fractions. That's what we're going to do. So that's going to give us g of x times f of x plus h minus f of x. So all that's going to be over g of x plus h times g of x times h. So we have that fraction minus this fraction over here, f of x times g of x plus h minus g of x, all over this g of x plus h times g of x times h. And it's the limit as h approaches 0. All right, cool stuff. So now we got these two fractions. So now we're going to kind of arrange them so they look better for us. So what's going to be better? Because remember, our whole goal was to be able to find, where was it? This limit definition of the derivative again. That's part of this idea. And now we've found it because we have it right here. So we have f of x plus h minus f of x over h. And so we're going to rewrite this as like two fractions multiplied by each other. So that's g of x over g of x plus h times g of x times h. And then this over here is, we're going to find our g of x plus h minus g of x over h, and then minus f of x over g of x plus h times g of x. So see how we just broke up both of those fractions. So like here's the limit part that we wanted here. That's this. And then we have the other part right here. That became this fraction. And that happened with both of these. You see again, here's this part that's right here. Ooh, except for that was a good check because there's not an h there. Because the h went with this part that was right here. And of course, it's the limit of all these things. The limit as h approaches 0. And now we're ready. Because now if we've got all this stuff multiplied and subtracted, we can just like take the limit and plug in 0 for all of them. And so what happens when we do that? Well, those two pink things there, notice that that is exactly the definition of the derivative. So when we actually take the limit as h approaches 0, those pink things there become, that's the derivative of f, and that's the derivative of g. And then what else happens when we plug in h equals 0? Well, this still is still g of x. But then here, when we plug in h equals 0, it's just g of x plus 0. So that's g of x times g of x. So that's where we're getting g of x squared. And then over here, similar things. We have f of x over g of x squared. And of course, these g of x's could cancel in the beginning, but if you know what the quotient rule is, you see that we basically have it, because this can be written as just, those are just one fraction, because that's just over 1. And then now we're subtracting fractions, but they already have the same denominator. So we can see what we have here is f prime of x times g of x minus g prime of x times f of x, and all of that is over g of x squared. And that is the quotient rule. That is how you take the derivative of a function divided by a function. And that was derived from scratch. That was beautiful. So now that we know what the quotient rule is, only took a page and a half of paper, we can actually apply it. Because of course the beauty of these formulas is you're never going to have to derive that again. I think that might have been the first time that I derived that from completion. But now we can just use it. So now if we want to use it, we see that this is our top function, our f of x. This is our bottom function, our g of x. So we're going to do the derivative of the top function, 5, times the bottom function, and then minus the derivative of the bottom function times the top function, and then all of that divided by the bottom function squared. And that's beautiful. That's the derivative. It's kind of nice to just clean it up maybe a little bit. So let's distribute that 5 and that negative 2x. So plus 4x. And then just combine like terms. We're not going to distribute the bottom, because anything we're going to want to do with this fraction, it's always nicer if things are factored. So the only reason we're like doing it for the top is because like that's not nice. It'd be nicer to look like a quadratic. So what does this look like if we simplify it all the way? So we have negative 5x squared, and then plus 4x plus 5. And that's pretty good. We're not going to be able to factor that, I don't think. So that's the derivative. That is the derivative. Now that you know the quotient rule, the biggest thing to remember about the quotient rule is that it's the derivative of the top function first. Because the top function is f of x, so it's the top function first. And that doesn't matter for product rule because it's addition, but for quotient rule that does matter because it's subtraction. So remember, it's the derivative of the top first times the bottom function minus the derivative of the bottom function times the top function, and then divided by the bottom function squared. Don't forget that it's squared. But that's beautiful. That's beautiful.